let's turn to the second page of this worksheet here, and we got ourselves another table of data. Excuse me. This table gives the U.S. city average for a gallon of gasoline in the United States from, and this is where we'll do a little correction here because it's really not from 1981 to 2011, but from 2007 to 2013. So, the first thing it asks you to do is make a scatter plot of this data on your calculator. So again, enter your data into list 1 and into list 2. So you may want to pause the video for a second here. Now, just show you how I've entered in my data already. So if I go to Stat and Edit, my data is already in here. So again, to do the stat plot, I'm going to go to the first one. Mine was on from the last problem that we just did. So I can go ahead and hit graph, but again, it's not going to show up until I go zoom 9. And there's my data. You can definitely see there's a linear pattern, a couple data points here, kind of towards the bottom are a little bit farther away, but we can still see there tends to be at least a positive, somewhat linear pattern going on here. So now, in part B, it asks you to find the linear regression of your regression line around the slope and y-intercept to 4 decimal places. So going back to my calculator, if I go to Stat, Calculate, number 8, linear regression, there I get my slope and my y-intercept. Notice in part C it also asks for the correlation coefficient, so I'm going to actually probably note that here and see or jot that down here in just a second. So my equation, y hat, is going to be negative 486.4171, 4 decimal places, plus 0.2436x. So I got my prediction line equation. My part C asked me for my correlation coefficient, which was 0.789. And that was asked to be rounded to 3 decimal places. And it asked you to describe what it tells us about our data. So what it tells us is our sentence should go something like this. We have a, now is it weak or strong? Since it's above 0.5, we're going to say strong. Our slope is positive, so our correlation also here was positive. So we have a strong, positive, since we're talking about lines, linear relationship . So we'll say relationship, and then we say between what variables? Well, what are we comparing here? Well, we're comparing the year, so it's between the year and the gas price. So, there's part C. D says use our equation to predict the year when gas prices, sorry, it says past prices, should say gas prices, will reach $5 a gallon. So, we want the year. The year is X. When the gas prices reach $5 a gallon, that's going to be our predicted Y. So, on this particular problem, we're going to replace Y hat with 5 and solve for X. So negative 486.4171 plus 0.2436x. So here I'm going to add 486.4171 to both sides. So when I do that, I get 491.4171 equals 0.2436x. So I'm going to divide both sides by 0.2436, and I get x to be 2017.311. So that answer seems to make sense. So I'm just going to round it to the nearest year. So we can say in the year 2017, we can expect or predict to see $5 or $5 a gallon for gas. All right, that takes care of number 2. Okay, now let's move on to number 3. So again, here it says, here are some more data from the small town swimming pool showing the relationship between temperature and the number of visitors at the pool. So it asks you to make a scatter plot. So again, take a minute, enter this data into list 1 and list 2. If you need to pause the video, do so right now and then just come back to it when you're ready. Okay, so what I now can do, whoops, didn't want you to actually see it, is do the scatter plot. So first thing I want to make sure is, do I have my data here in my calculator? List 1, list 2, which I do. So if I go to my scatter plot, second y equals, turn the plot on, then when I hit graph, now mine's going to show up, but if yours doesn't, zoom 9, and it shows up relatively nicely. So now, looking at this scatter plot, question A asks you to try to predict the correlation coefficient. Now, the closer this is to a straight line, the closer it is to 1 or -1, whether it's going positive or negative. So this one, looking at this one, you got a lot of points that are relatively close, but you have this bottom point down here that's a little bit not quite there. So this point is going to impact it a little bit. So there's a part of me that wants to say 0.8, but this point I think is going to cause it to be something more like 0.5. So that's the one that I'm going to go with and see what happens later. Now the next thing it asked me to do is pick 2 points that best describes the data linearly if we were to graph it. So I'm definitely going with this bottom point down here. Okay. So if I do my trace key, this 68,280, then I'm going to jump around. Whoops. Oops, I got to hit my trace key, sorry again. And I'm going to look for that one up top, which is 100, 500. So I'm going to note both those 2 points again. 68,280 and 100, 500. So now, it then asks me to write the equation to it. So I need to use these 2 points like I've done before and find the slope. So to find my slope, change in y, so 500 minus 280 over change of x, 100 minus 68. I believe we actually did this before with these 2 exact points, 6.875 in a previous problem. But in the directions it says round the slope to a whole number. So this is going to be rounded to 7. So now, depending on what 2 points I use, or what point I use, I could have one of 2 equations. I get y hat equals 280 plus 7 times x minus 68. That was for the first point. Or for the second point, which I'll do here, I could have y hat equals 500 plus 7 times x minus 100. Now, depending on which equation you use, you will get a slightly different answer for your part C and your part, or for part C, I should say. So if I use the one in red, it says use your equation to predict the attendance at the pool on an 85-degree day. So on both of these, we're going to just let x equal 85. So my predicted y would be 280 plus 7 times 85 minus 68. So if I simplify this and plug it into my calculator, my answer ends up being 395 people. However, if I use the other prediction equation, y hat equals 500 plus 7, and I go 85 minus 100, and I multiply that, I get 399 people. However, I do want to check something here. Because if I go 85 minus 100, I have a feeling I might have these two answers flip-flopped here. Just a second. So let me just double check with my calculator. So if I go 280 plus 7 times, in parentheses, 85 minus 68. Just going to double check it. 399. I did have these flipped. So this should be 399, and this answer should be 395. Glad we caught that. All right, part D says calculate out the correlation coefficient, round your answer to 3 decimal places, and again, what does it describe about the data? So let's see how our prediction of 0.5 ended up being. So I go back to my calculator and go stat, go over to calculate, number 8, hit enter. Okay. There's the linear regression equation. We actually didn't use that one, but here I have our value of 0.515. It is above 0.5, so we'll still use strong, but what I like to do is throw just a little adverb in there. So we have a fairly strong, then it was positive, and again we're talking linear relationship between the outside temperature and pool attendance. That ends page 2 of the video.